So let's talk about the first task. The Arduino program is designed to control 3 LEDs such as red, blue, and green connected to the Arduino board. It makes the LEDs light up one after the other in continuous seconds, with each LED staying on for 1 second before the next one light. In the code, the first 3 lines define 3 variables and assign them to digital pin 13, 12, and 11 on the Arduino board. The setup function runs once when the Arduino is powered on or reset. Pin mode sets the mode of the specific pin. Here it's set pin 13, 11, and 12 as output, meaning this pin will be used to send signals. Also, the loop function runs continuously after the setup function completes. Digital white sets the specified pin to either high or low. So let's talk about the second task. This Arduino program is designed to control 2 sets of RGB LEDs by creating random colors. It assigns each color components of the RGB LEDs to specific pin. The first lines created variables for each color component of the 2 RGB LEDs. The pins for RGB1 are 13, 12, and 11. The pin for RGB2 are 10, 9, and 8. The setup function runs once when the Arduino starts. It uses the pin mode function to set the pin for both RGB1 and RGB2 as output pins. This means the Arduino can control this pin to change the color of the LEDs. Also, I wanna add that the loop function runs repeatedly in the cycle. Inside the loop, the random 0 to 55 and analog white. And also, a value of 0 means the LED is off, and 255 means it's fully on. So the next is task number 3. The Arduino program is designed to control 2 sets and make them display random colors 5 times during the setup phase. The first lines create variables for each color component of the 2 RGB LEDs. The pin for RGB1 13, 12, 11, and the pin for RGB2 are 10, 9, and 8. So the setup function runs once when the Arduino starts. It uses the pin mode function to set the pins for both RGB1 and RGB2 as output pins. This means the Arduino can control this pin to change the color of the LEDs. Inside the setup function, there is a for loops that runs 5 times. During each interaction of the loop, the random, analog white, delay 500. The loop function runs repeatedly in the cycle. In this case, it's empty. So the next is task number 4. This Arduino program controls the RGB LEDs and changes its color based on state of push button. The first lines create variables for the RGB LEDs pins and the push button pin. The RGB LEDs pins are 13, 12, and 11. The push button is connected to pin 10. The variable's bottom state will store the current state of push button. The setup function runs once when the Arduino starts. It uses the pin mode function to set the RGB LEDs pin as output pins. The loop function runs repeatedly. Inside the loop, digitally read bottom and stores it in bottom state. If the push button is pressed, the red and green LEDs are set to the brightness of 200 and the blue LED is turned off. So the next is task number 5. The Arduino program controls the RGB LEDs and push button and piezo buzzer. The LEDs change the color and the piezo buzzer sounds based on the state of push button. So the first lines create variables for the RGB LEDs pins, the push button pin and the piezo buzzer pin. The push button is connected to the pin 10 and the piezo buzzer is connected to pin 9. The variable bottom state will store the current state of push button. Based on analog white, red LED 200 and so on, the red and the green LEDs are set to the brightness of 200 and the blue LED is turned off. And also based on the tone piezo 400 and 2000, the piezo buzzer sounds at 200 for 2 seconds. So the next task is number 6. The Arduino program used an LCD to display the temperature read from the analog sensor. The include line includes the liquid crystal library, which allows you to control LCD display with Arduino. The liquid crystal LCD sorting and so on line initializes the LCD object with the specified pins for communication. The setup function runs once when the Arduino starts. Inside the setup function, pin mode sensor input sets the sensor pin A5 as an input pin. LCD begin 16 to initialize the LCD with 16 columns and 2 rows. So the next task is number 7. This Arduino program used an ultrasonic sensors to measure distance and control and LEDs based on the measured distance. The first lines create variables for the distance in centimeters and the trigger and echo pins of the ultrasonic sensors and the LED pin set to the 7. The setup function runs once when the Arduino starts. Inside the setup function, the LED pin is set to the output mode. The serials begin 9600 initialize the serials communication at a bound rate of 9600 for debugging or data sharing with the computer. So the next is task number 8. The Arduino programs integrate an LCD display, an ultrasonic sensor, and a LED and piezo buzzer. The ultrasonic sensor measures distance and LCD display a warning if an object is too close. They include liquid crystal. Line includes the liquid crystal library, which allows you to control LCD display with the Arduino. The liquid crystal LCD line initializes the LCD object with a specific pin for communication. Also, there are create variables for the temperature sensor, temp and sensor, and the ultrasonic sensors, CME, trigger, echo, and the LED pin LED, and the piezo buzzer pin is piezo. After a short delay, a high signal is sent to the trigger pin for 0.1 milliseconds to generate the ultrasonic burst.